Hello everybody, we're going to take another look at scalars and vectors. To do a quick review, remember that a scalar quantity has magnitude only, so it has size only, like length, area, speed, temperature. It's just a measurement. A vector quantity has both magnitude or size and direction. So if I talk about running at 5 miles per hour, that's a scalar quantity. That's a speed. It's a measurement only. If I talk about running at 5 miles per hour to the right, then it becomes a velocity and a vector quantity. So one more time, vector quantity has both magnitude and direction. By the way, if you're interested, I pulled this graphic from the NASA website, and there's a link to it. So I want to do a quick review of adding vectors. Remember, we have two ways of adding vectors. Notice that the vectors that we're going to add are in component form or XY form. And so if I have vector A, it's represented by 4, 4. That means that if I go to the point on the coordinate plane of 4, 4, so that's to the right 4 and up 4, this point is not my vector. The segment that I draw from the origin to that point is my vector. So this is vector A. Vector B, if I was just going to measure the vector, would be starting at the origin and going to the right 2, down 4, but that's not what we're going to do. We're going to be adding the vectors, and if we're going to add B onto A, what that means is I start here at the vector A, and I add B onto it. And so vector A ends right here. I am going to add onto that the point 2, negative 4, and so I go to the right 2, down 1, 2, 3, 4, and end up there. Again, that point does not represent my vector. This segment represents my vector. And so that's vector B. And I've now added B onto A. The resultant is the vector that I would get if I started right here at the beginning and went to the end point. So think about it like you're walking along a path. To add A plus B, you can walk along the path for A and then walk along the path for B and end up here. Or to get the resultant, the addition of the vectors, you can start at the starting point and go straight to the ending point and end up there. There we go. Let's make it visible. There we go. And so we end up here. Those coordinates represent the vector of the resultant in component form. And those have the coordinates of over 6, up 0. So A plus B would be 6, 0. Now remember, there is an easier way of doing that than by drawing the vectors. When the vectors are in component form like they are here, XY form, all that you need to do to add the vectors is add the X coordinates and add the Y coordinates. And so if I separate them out, if I add the X coordinates, 4 plus 2 is 6. If I add the Y component of the coordinate, 4 plus negative 4 is 0. There's my answer as well. So while it's nice to get used to drawing the vectors and understanding what the resultant is, it's okay to use the shortcut of just simply adding the X component and the Y component. And that's the resultant. So I'd like you to think about this for a moment. Does A plus B have the same resultant as B plus A? So think about that. You might want to pause the recording and come back to it. A plus B is just like before. I'm going to start with vector A, draw vector A, add vector b onto it. That would be over 2 down 4. And then get the resultant. There's the resultant. And so there's the 6, 0 again. Now let's think about if we start with b and add on a. So this time we're going to start with 2, negative 4. I'm going to change color so you can see the difference between the two. So I'm going to start with 2, negative 4 and add the 4 onto that. So if I start with the 2, negative 4, that first vector b, I go over 2 and down 4. There's that vector. If I add a onto it, I start at the end of vector b now and add on a. 4, 4 means I go to the right 4. 1, 2, 3, 4. And up 4. 1, 2, 3, 4. And I end up right there. Look at that. So that's where I end up. There's my resultant. And so, although the path is different, with a plus b we followed this path, with b plus a we followed this path, the path is different, the resultant is the same. We still end up at 6, 0. And if you think about it, addition is commutative. Remember the shortcut. Adding these and then adding those. Addition's commutative, doesn't matter what order you add in, you're always going to get the same answer. So let's think about that now with subtraction. So let's talk about vector subtraction. Vector subtraction is exactly what it sounds like. You're subtracting vectors. But what happens with vector subtraction, subtraction means to move in the opposite direction. So let's take a look at what I mean. Let's start with vector p, and we're going to calculate here. We're going to draw p minus q. So we're going to start with vector p at 3, 4. And remember, that's not the vector, that point. This segment is the vector. Subtraction with vectors means move in the opposite direction. So in this case, when I start with vector p, and I'm going to subtract vector q, starting here at the end of p, vector q is 2, 6, but I'm not adding, I'm subtracting. So that means instead of moving 2 to the right as I would, I'm going to move 2 to the left. 1, 2. Then I have a positive 6, so instead of moving 6 up, I'm going to move 6 down to subtract. 1, 2, 3, 4, 5, 6, and I end up there. And remember again, that point does not represent my vector. This segment does. So if I walked along the path of p minus q, this is where I would end up. Here is the resultant. And that resultant has the coordinates of 1, negative 2. You can use the same shortcut for subtracting vectors that we do for adding them. So simply subtract the x component, subtract the y component. So if I start with 3, 4, and I subtract 2, 6, I'm just going to take 3 minus 2 gets me 1. 4 minus 6, that's negative 2. And if you look, this matches the answer we got through drawing. Now I want you to think for a moment. Will p minus q have the same result as q minus p? We just did p minus q. In fact, I think I'm just going to snap this image and move this back. Move us back to the prior page. There we go. Think about this. Will p minus q have the same resultant as q minus p? So let's switch colors and draw q minus p. Q minus p means I'm going to start with q, 2, 6, and subtract p, 3, 4. So I'm going to go over 2 and up 6. 1, 2, 3, 4, 5, 6. There is vector q. Now let's draw vector P, but subtract it. So P was 3, 4, but we're going to subtract, so I'm going to go in the opposite direction. To the right 3, down 4, and I end up there. Notice, this time my resultant is different. Here the resultant is -1, 2. And so P minus Q and Q minus P are not the same thing. Very similar to plain old addition and subtraction. Addition is commutative, subtraction is not. And so vector addition is commutative, vector subtraction is not. The shortcut to subtracting vectors is exactly the same though. I'm going to start with Q, subtract P. This time I have 2 minus 3, that's -1. 6 minus 4 is 2, and there is that resultant of -1, 2. So what you need to understand is that vector addition is commutative, vector subtraction is not commutative. So I would like you to try this vector subtraction right now. Vector W has the coordinates of 4, 4. Vector T has the coordinates of 2, -4. I would like you to calculate W minus T and choose one of these answer options here. You can pause the recording while you think about it. Okay, so hopefully you have an answer. If we're going to draw this out, to calculate W minus T, I would start with my first vector, 4, 4. There it is. And then I'd subtract the 2, -4. So from here, I would go left 2, because I'm subtracting and going in the opposite direction. And then instead of going down 4, I would go up 4. And end up there. That's the vector subtraction. Now I'm drawing the resultant. And so, let's see, that's 2, 8. The other way to subtract them would be to start with W, subtract T. Remember that you're subtracting the X component and the Y component. 4 minus 2 is 2. 4 minus -4, ding ding ding, alarm bell should be going off when you subtract a negative, it becomes plus positive. 8. There's our answer. This time I'd like you to calculate T minus W. So we're going the other way now. Again, I'm going to hold for a moment. You can stop the recording if you need more time to think. So we're going to use just the shortcut method. I'm not going to draw this one out. So if I have T minus W, I'm going to start with T. I'm going to subtract W. And when I do that, I subtract the 2 minus 4, the X component. That gets me -2. I subtract the Y components, -4 minus 4. That's -8. And so the answer to this one is B. And here are 4 for you to try. I've given vector M, vector N, and vector P information to you. You can see that up there. Remember, this notation is the shortcut for writing vector. This means vector M. This means vector N. And so right now, I'd like you to pause, after you listen to this, pause the recording then, and calculate vector M plus N, and M minus P, and N plus M plus P, and N minus P plus M. When you've calculated it, write your answers down. Come back to the recording. I'm going to provide the answers for you to check. If you have questions because you can't come up with the correct answers, or there's questions you have about anything in this recording, let me know. So pause the recording now, come back to check your answers when you're done. Okay, so here are the solutions. Like I said, if you have questions, if you're confused about anything, or if you can't come up with those solutions, let me know, and I'll be happy to explain.